part 2 of topic 4 electrochemistry, lesson 2 electrolysis in chemistry 0620 Cambridge IGCSE. So we're going to be continuing our practice on solving electrolysis on molten ionic compounds. Okay, but we're going to start now without the diagram and using the observation notes we have studied in the last part of the previous video. Alright, so continuing from example 3. Electrolysis of molten aluminum chloride. There's supposed to be an L here, my bad. Right? So first, identify the decomposition equation. Aluminum forms a positive 3 cation and chlorine is -1. Okay, what is the positive cation? Aluminum. So where does the positive cation go? To the cathode. What happens to the cathode? Reduction. Electrons are gained in the reactant side. So aluminum plus 3 electrons relevant to its charge gives aluminum. Aluminum forms a shiny silver, okay? Anode is oxidation. What is oxidized? Chlorine. Negative anion moves to the anode and becomes oxidized. Oxidation is loss of electrons. Chlorine is diatomic, so it will lose 2 electrons, 1 electron per atom. Chlorine forms pale green bubbles. Electrolysis of iron bromide. I'm gonna let you do this question by yourself, okay? See if you got the answer correct. You can refer and pause the video here. Okay, common electrolysis of molten compounds. So this is a quick summary of some very, very common electrolysis equations that you're going to be seeing in the exam. So electrolytic compound that being electrolyzed in the first one is lead bromide. Lead is positive, so it will go to the negative electrode. Bromide is negative, it will go to the positive electrode. In the cathode, lead is going to gain electrons, become reduced 2 electrons. Anode is going to lose 2 electrons, becoming oxidized. Sodium chloride, we've already done this one. Sodium goes to the cathode, chloride goes to the anode. At the cathode, sodium gains electrons, and the anode, chlorine loses electrons. And you can review the other examples by yourself. Now let's come to electrolysis of aqueous dissolved compounds. Like I said, aqueous dissolved compounds can either be an electrolysis form of a dilute solution or a concentrated solution. First, we will cover the concentrated solution and how to solve that. After that, we will move to the dilute solution. So what is an aqueous solution first? If you don't know what's an aqueous solution is simply a solution with 2 sources. Water, which is hydroxide plus hydrogen, and a compound, okay? All dissolved ionic compounds, whether concentrated or dilute, are always aqueous solutions, okay? So now I want you to learn first, how do you identify the aqueous solution and how do you deal with it? For example, AB here is our compound, okay? As soon as you see the aqueous symbol, I need you to draw a cross-section table. On the top, place the compounds that form water. In the bottom, place in the compound that you're dealing with, positive above positive, negative above negative. So what forms water? Positive hydrogen and negative hydroxide. And then put the compound A positive, B negative. Let's have a few examples here to see what I'm trying to say. Copper sulfate. Aqueous. Oh, there's aqueous. What should I do now? Make a cross-section table. On the top, hydrogen positive, OH negative. What is positive? Copper. So hydrogen positive, copper positive. What is negative? Sulfate. So sulfate negative, hydroxide negative. Okay? Compound that forms water, compound that forms compound. What is this? Your aqueous solution. 2 sources, water and compound. Got the idea? Let's have a look at another one. Sodium chloride. Aqueous. Okay, what do I do first? Make a cross-section table. After this, on the top, form the water. Hydrogen positive, OH negative. Below, hydrogen positive, so sodium negative, positive. Hydroxide negative, so chlorine negative. Another one. Aqueous solution, cross table, hydrogen positive, or hydroxide negative, this forms water. Hydrogen positive, so golden positive, and nitrate negative, hydroxide negative, okay? So basically, this is what you're supposed to do as soon as you see the aqueous symbol in a compound, okay? Why do we do this? We're going to learn when we see how to solve the electrolysis equations of aqueous dissolved compounds. Alright, but before we do that, now I think there's something confusing here, right? We have two negative ions and two positive ions. So how do I know which negative ion is gonna go to the uh, which negative ion is going to the anode and which positive ion is going to go to the cathode, right? For example, here you have hydrogen and copper, hydroxide and sulfate. Which of these negative ions will go to the anode and which of these positive ions will go to the cathode? Which one is going to be electrolyzed? This is where the reactivity towards the electrodes come in. So to find the reactivity towards the electrodes in a concentrated, I say again concentrated, aqueous dissolved solution or anion compound, to determine which negative ion moves, okay, or reacts at the anode first, we use the anion speed table. And to determine which positive ion reacts first at the cathode, we use the reactivity series of metals. Now we're going to have a look at the both of these. First, let's determine the reactivity towards the cathode. All right? Sorry, the anode. So in a concentrated solution, we use the anion speed table. First to react is going to be chlorine, bromine, iodine. Then hydroxide will react. Then the polyatomic ions. Okay? So this will react first, react second, react third. Okay? So in a concentrated solution, aqueous solution, the first negative ion to react to the anode is going to be chlorine, bromine, iodine, one of these, like the halogens, then hydroxide, then polyatomic ions. To reactivity towards the cathode, which positive ion will react, we use the reactivity series of metals. The reactivity series of metals is potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, iron, lead, hydrogen, copper, gold, and silver and gold. But I'm not going to use that. I'm going to show you this. This is how you need to remember the reactivity series of metals. I mean, look, you don't have to remember it like this, but personally, this is how I advise you to remember it if you have never memorized it before. An amazing mnemonic. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. Okay? Just remember this sentence. It's very easy to remember. And just relate the first letter to the element. Please, P for potassium. Stop, S for sodium. Calling, Cal, calcium. Me, magnesium. A for aluminium. Careless, Car, carbon. Zebra, zinc, ZZ. Instead, iron, II. Try, T for tin. Learning, Le, lead. How for hydrogen. Copper is copper. Saves, S for silver. Gold is gold. So just remember this and trust me, it's going to be very easy for you. As you're going from down to up, least reactive to more reactive, okay? Always remember the least reactive metal reacts first, okay? So now we're going to have a look at some examples, all right? Let me just reset the camera here, 1 second. Okay. So, example 1, electrolysis of dissolved sodium chloride. I know it looks very complicated, but don't worry. It's very easy. The first thing, aqueous symbol, what do? Cross-section table. Form water, form the compound. Hydrogen positive, hydroxide negative. Hydrogen positive, so sodium positive. Hydroxide negative, so chlorine negative. Which of these positive ones is going to react at the cathode? Which one is less reactive? If you refer to the reactivity series of metals, hydrogen is less active than sodium. Hydrogen will react first at the cathode. It will be reduced, meaning it will gain electrons in the reactant side. Which of these is going to be oxidized first? Again, in a concentrated solution, we said chlorine, bromine, iodine reacts first, then hydroxide. So chlorine is diatomic. It will lose 2 electrons in the product side. What is the observation of chlorine? Pale green bubbles. Now, what has been used? Chlorine and hydrogen are used in the electrolysis. What is the compound that is remaining? Sodium and hydroxide. Cross arrangement. Sodium hydroxide is the compound that is remaining. Okay? A quick note, when hydroxide is left after an electrolysis reaction, the compound is a basic compound. Okay? Going for another example, electrolysis of dissolved copper sulfate. Again, it is an aqueous solution. Because it's an aqueous solution, what is the first thing you do? You make the cross-section table, right? Form water from the compound. Hydrogen positive, OH negative. Hydrogen positive, so copper positive. Hydroxide negative, so sulfate negative. Which of these is going to react first at the cathode? Which one is less reactive? Copper is less active than hydrogen, so copper will react first. How many electrons will it reduce? It will reduce 2 electrons because the charge is positive 2. What about hydroxide and sulfate? According to the anion speed tables in concentrated solution, hydroxide reacts first, then polyatomic ions. So the hydroxide oxidation equation needs to be remembered, okay? You must memorize this equation. 4OH negative will give you 2H2O plus oxygen plus 4 electrons. Oxygen is gas, water is gas, and OH is aqueous. Remember this equation, as in the exam they might ask you to just write the equation, or they might hide some part of the equation and you have to fill in the blanks. So this is very important and needs to be memorized. Constant equation to be memorized. What has been used? Hydroxide, copper. What is remaining? Hydrogen, sulfate. What is the compound left? Combine hydrogen and sulfate, sulfuric acid. The last one, I'll leave it up to you to solve this question. Great, so we have covered how to solve electrolysis in ionic compounds, in molten ionic compounds. We have covered how to solve electrolysis in aqueous, dissolved, concentrated ionic compounds. Now, let's have a look at how to solve electrolysis in aqueous, dissolved, dilute ionic compounds, okay? The rules for the metals remain the same. For the reaction of the metals, we use a reactivity series of metals. Okay, the least reactive reacts first. But the rules for the reaction at the anode will change, okay? The anion speed table is altered, just slightly. You just switch the first two. In a dilute solution, hydroxide will react first, then the halogens, chlorine, bromine, iodine, and then the polyatomic ions. If you remember concentrated solution, these react first, then hydroxide, then this. In dilute solution, hydroxide first, then these, then polyatomic ions. So let's have a look at some examples, of course, starting with the classic sodium chloride. Dilute sodium chloride. Again, aqueous. What is the first thing you do? Cross-section table. Form water, form the compound. Water is hydrogen and hydroxide. The compound is positive sodium, negative chlorine. Which of these metals will react first? Which one is less active? Hydrogen. So hydrogen will react first where? Hydrogen is positive. It will go to the cathode. Cathode is reduction. Hydrogen will gain 2 electrons in the reactant side because it is diatomic. Which of these will react first? According to the anion speed table in a dilute solution, hydroxide will always react first. And for the hydroxide oxidation equation, you must memorize this equation. Electrolysis of this dilute compound. Make the anions, make the cross-section table. Form water from the compound. Hydrogen positive, potassium positive. Hydroxide negative, bromine negative. Which of these reacts first? Which one is less active? Hydrogen is less active, it will react first. It will gain 2 electrons at this diatomic. Hydroxide and bromine, it is dilute. Hydroxide reacts first. Memorize this equation. This is a summary. You can pause the video and read through it. We have already solved these questions. And that is it for topic 4 electrochemistry, lesson 2 electrolysis. And I will see you in the last episode of this topic 4 electrochemistry in chemistry 0620 Cambridge IGCSE. Any questions, I'll be more than happy to answer them in the comments below, and I will see you in the next one.